Hello friends, I am the final year student of Weltec University is going to present you all my final semester project on the topic of performance of the diesel engine with the help of varying injection pressure. This project is made and prepared by myself Ankit Pandey and my friend Sumit Kumar Avda. I have done this project under the guidance of our gracious Sir Mr. J.M. Babu sir who have done his MTech from Thermal and is the assistant professor of Weltec University in mechanical department. So friend, this is the abstract part of our project in which I will tell you the objective of our project. As we all known to the fact that fuel crisis and environmental concerns have led to look for the alternative ways to save our conventional fuels. This can be done by using the alternative fuels that is biodiesel, CNC, natural gases and many other fuels or alternative fuels are available. So we have used the phenomena of varying pressure through the fuel injector in the combustion chamber so that we can increase or enhance the performance of the engine. Like that, so we have made our objective to work the effect of varying injection pressure on the injection performance. So we have done this experiment on the single cylinder Kirloskar 4-stroke water cooled vertical direct injection diesel engine. The experiment is conducted by changing the injection pressure from 175 bar to 375 bar with an interval of 50 bar by applying load ranging from 0 to 17.8 kg on rope brake dynamometer with the engine running at pure diesel mode. At different injection pressure, we have observed the result of performance parameter and exhaust emissions. This is the introductory part of our project in which I will explain you how injection pressure plays a vital role in diesel engine for its performance and exhaust emission. When the injection pressure is low, fuel particle diameter are large and ignition delay period during the combustion will increase. This situation leads to increased pressure in the combustion chamber and engine performance will decrease as the combustion goes to incomplete. When the injection pressure is increased, fuel particle diameter will become small and mixing of the fuel and the air become better during the ignition period and the engine performance will be increased. But if the ignition pressure is so high, then the fuel particle will not penetrate and the possibilities of homogeneous mixing decrease and combustion efficiency will fall down. So in this page, this is the objective of our project that I have explained you in the abstract part. The main objective of the work is to show the effect of the varying injection pressure on engine performance and exhaust emissions. Well guys, this is the schematic diagram of the fuel injector showing the different parts. Simply now I am telling you the function of the fuel injector that we have learned in our engineering period. As you all know, fuel injectors are used to spray controlled amount of fuel in the combustion chamber that I have explained you in the introductory part. Usually a fuel injector has a solenoid that is activated when the fuel is intended to be delivered to the engine, causing the plunger to become pulled toward the solenoid by the magnetic force. This uncovers the valve opening, allowing the fuel to flow into the atomizer and out the spray tip as it is under pressure. A valve spring is attached to the plunger to its original position when the solenoid is switched off. Injection of fuel is achieved by location of cam on the camshaft. Well, these are the different kinds of SIMs that are available in the market that we can use in the fuel injector to vary the pressure. We can also vary the pressure by screw adjustment, lift, or needle lift adjustment, and pressure ranges. We can test the pressure by using the fuel injector pressure testers. Well, these is the 3D modeling of the fuel injector. We can make it by using different 3D software like CATIA, ProE, AutoCAD also we can use, and Autodesk Inventor. And there are many software that are available. We can make it. The right one figure is showing the sectional view of the fuel injector, which is showing the spring, plunger, barrel, spindle, needle wall, and nozzle tip. All these parts are clearly shown in the right figure, and the left one figure is the one piece constructional view of the fuel injector. So guys, this is the important thing. By using this we can test the pressure at the fuel injector. That I have told you, these are used to test the pressure. This is nothing but the fuel injector tester that is used to test the pressure at the fuel injector of varying injection pressure. Injection pressure. This is the image taken by high speed camera. The left image is showing the injection of fuel at normal pressure, that is 175 bar. We can see that there are the crevices area which remained, means that the fuel is not reaching there, so that the air and fuel utilization will not occur. Utilization means that the mixing of the air fuel mixture is not better, so that the combustion will remain incomplete. But in the right image we can see which is injection of fuel occurring at the high pressure, so that it will cover the more crevices area inside the cylinder, so that the utilization of air fuel mixture become better and the combustion is complete. These are the engine specification on which we are doing our project. The bore of the engine is 80 mm, the stroke is 110 mm, the swept volume of the engine is 553 centimeter cube, and the compression ratio of the engine is 16.5, and speed of the engine is 1500 rpm, and the rated output of the engine is 3.75 kilowatt, that is nothing but the 5 horsepower. Friends, this is the layout of our experimental setup. It is shown that point 1 is the air inlet and point 2 is the orifice meter through which the air is getting inside the mixing chamber, and fuel tank is there, which is connected to the burette, and there is the engine which is connected to the mixing chamber. Engine is directly coupled with a rope brake dynamometer which is used to apply load, and exhaust gas analyzer is a separate unit which is put inside the chimney at the exhaust stroke to analyze the exhaust emissions. So what is happening here is that the air from the air inlet, that is the red ball, is getting inside the mixing chamber. At that same time, the fuel from the fuel tank through the burette is let to get inside the mixing chamber. They get mixed and then it is allowed to get inside the cylinder at the inlet stroke. Now the combustion will take place inside the cylinder at the power stroke, and exhaust gas analyzer is allowed to put inside the chimney. The exhaust gas analyzer is coupled with the computer in which the pre-installed software will give you the smoke head and the amount of and types of emission which are coming at the outlet. So now it is the time for result and discussion that we have made after completing our whole experiment. So in result and discussion we have plotted graphs at various injection places of showing the engine performance parameters and exhaust emissions, in which we are showing the variation of consumption with brake power, variation of fuel consumption with brake power, variation of brake thermal efficiency with brake power, variation of mass of air with brake power, variation of air fuel ratio with brake power, and variation of volumetric efficiency with brake power. Apart from this, we have also included the exhaust emission. In exhaust emission, we have also plotted the graph that is showing the variation of CO2, oxide of nitrogen, oxides of carbon with brake power and their amount released at different injection pressures. So here is the first graph that is showing the or plotted between the fuel consumption with brake power. This showing the figure the variation of fuel consumption with brake power at different injection pressure, that is 175 bar, 225 bar, 275 bar, 325 bar and 375 bar. When the engine is running with only diesel initially at 175 bar injection pressure at maximum load, the fuel consumption is 1.0073 kg per hour. But at 375 bar injection pressure, the fuel is 0.8717 kg per hour. So, therefore, the results are showing that the total fuel consumption saved is 0.135 kg per hour. This shows that as the injection pressure increases, the fuel consumption is decreasing. At higher injection pressure, less amount of fuel is required to produce same amount of power. This graph is plotted between the specific fuel consumption and brake power at various injection pressure of 175 bar, 225 bar, 275 bar, 325 bar and 375 bar. The figure shows the specific fuel consumption variation with brake power at different injection pressure. As the injection pressure increases, the specific fuel consumption is decreasing, which means that the fuel efficiency is increasing. So this graph is plotted between the brake thermal efficiency and brake power at various injection pressure of 175 bar, 225 bar, 275 bar, 325 bar and 375 bar with diesel as a working medium. According to the result, at lower injection pressure of 175 bar, the brake thermal efficiency of the engine is 37.61%. At higher injection pressure of 375 bar, the brake thermal efficiency of the engine is 43.46%. This means that as the injection pressure increase, the brake thermal efficiency of the engine is increasing. This is because of the lower injection pressure. Combustion is not complete and more amount of unburned fuel leaves with the exhaust gases. At lower injection pressure, exhaust gas temperature is also high, which means that more residual gas when compared with the high injection pressure. At 375 bar injection pressure, more complete combustion is occurring, which means that very little bit amount of fuel is required to produce the same amount of power. This is the main cause of increased efficiency of the engine at higher injection pressure. An improvement of 5.8% is seen in brake thermal efficiency of the engine when the injection pressure of the engine is varied. Now this is the graph that is plotted between the mass of the air and the brake power at various injection pressure of 175 bar, 225 bar, 275 bar, 325 bar and 375 bar. Mass of air is nothing but the breathing ability of the engine. According to the result, as the injection pressure increases, the mass of air is increasing. This is because the temperature of the exhaust gas is high at lower injection pressure. At lower injection pressure, more amount of residual gas is wasted with the exhaust gas. At higher injection pressure, residual gas is less because the temperature of the exhaust gas is less compared to the high injection pressure. At lower injection pressure, less amount of mass of air will received by the engine, whereas high injection pressure, more mass of air is sucked by the engine cylinder. This is because higher injection pressure, the breathing ability of the engine will be good, when compared with the lower injection pressure. Now this is the another graph plotted between the air fuel ratio and the brake power at different injection pressure. The graph is shows the variation of the air fuel with brake power at different injection pressure of 175 bar, 225 bar, 275 bar, 325 bar and 375 bar. At lower injection pressure, less air fuel mixing cause less efficiency and high fuel consumption, whereas at higher injection pressure, perfect air fuel mixing cause less fuel consumption and higher brake thermal efficiency. So these are the exhaust emissions in SI engine and CI engine. In SI engine, that is the spark ignition engine, the exhaust emissions are of hydrocarbon, oxides of nitrogen, that is NO and NO2, oxide of carbon, that is CO and CO2, with oxide of sulfur, SO2 and SO3. With that, in compression ignition engine, the exhaust emission includes hydrocarbon, oxide of nitrogen, oxide of carbon, oxide of sulfur, particulates, soot and smoke. So our aim is to reduce these exhaust and increase the engine performance. So these are the exhaust emission analyzing equipment that we have used to detect and analyze the various kinds of exhaust gases. One of them is the exhaust gas analyzer, and one of them is the exhaust smoke head probe that is used to place at the outlet of the chimney to detect and analyze the kinds of emitted gases. This slide is showing the property of the exhaust gas that are emitting at the outlet. It is very important to understand the characteristics of these gases. The first one of them are carbon monoxide, that is usually of colorless, odorless, poisonous gas generated in an engine when compared operated on rich fuel equivalence ratio. Not only carbon monoxide is considered as the undesirable emission, but it also represents lost chemical energy that was not fully utilized in the engine. Carbon monoxide is the fuel that can be combusted to supply additional energy. So carbon monoxide is preferably to react with oxygen so that it can be converted into useful carbon dioxide. So maximum carbon monoxide is generated when engine run with rich mixtures such as starting, accelerating under load. Even at psychometric or lean, some carbon monoxide will generate in the engine. Poor mixing, rich mixer and incomplete combustion will create these carbon monoxides. Oxide of nitrogen is also one of the harmful gases at the outlet from the engine. The mixture of NO and NO2 will called NOx, nitric oxide, which is usually colorless, odorless, and is oxidized in the atmosphere to form nitrogen oxide. Nitrogen oxide is brown in color, acidic, highly corrosive, and can affect our health and environment. Nitrogen oxide are critically component of photochemical smoke. It will produce yellowish brown color of smoke. The reduction in NOx is due to the reduction in peak combustion temperature. The showing graph is plotted between the carbon dioxide and the. This graph is showing the variation of oxide. This graph is plotted between the. After plotting all the graphs and completed all required calculation, we came to conclusion. These the conclusion includes the performance characteristics of the engine working on pure diesel mode are plotted by varying the injection pressure. It was observed that as injection pressure increases, fuel consumption decreases, increasing the brake thermal efficiency, mass of air to fuel ratio, and hence volumetric efficiency increases with injection pressure. It was also observed that Injection pressure could not be increased beyond 375 bar. If the injection pressure is more than 375 bar, then it was observed that no fuel was injected from the inject. We have also concluded that the optimum injection pressure is 375 bar because at this injection pressure the engine is giving highest brake thermal efficiency of 43.46% at pure diesel mode. Hence, the overall improvement of the brake thermal efficiency observed is 5.85% by employing this technique. We have also concluded that exhaust emissions shows that hydrocarbon, carbon monoxide and oxide of nitrogen decreases as the injection pressure of engine is increasing from 175 bar to 375 bar. It was also observed that only CO2 increases with injection pressure in the case of pure diesel. So, guys, after making our conclusion, we are thinking that we can proceed our investigation in future. So, we have made 2 points that in these area we can proceed our work. If the same thing is applied to engine which is running with less efficiency, it will give more profit to the country. Also, this technique when we will apply with blends of biodiesel and providing more oxygen at the inlet, then the combustion would be more than usual and we can reduce much of the exhaust emission. These provision of oxygen at the inlet can be done by the process of electrolysis with the reaction between the hydrogen and oxygen that we can do in our future work. So, thank you, friends, for giving your time and seeing our slides regarding our project. Thank you very much.